Another characteristic that we'll be studying in section 1.2, day 2, is even and odd functions. With even and odd functions, it has to do with how the graph looks. So you see a couple examples here. We've got two graphs, and these graphs have some symmetry to them. A graph or a function is considered even if there is symmetry over the y-axis. So it's a mirror image. You can fold it over that line and it matches up. Odd is, so a function is going to be odd if it is symmetric over the origin. So we have to have this thing symmetric through the point 0, 0. There are functions that look symmetric. Maybe they don't go through 0, 0. They have to go through 0, 0 in order for this to officially be considered odd. So this is the graphical interpretation of even and odd functions. And you can look at a graph and just get an idea of what you think it might be. Now, in order to actually show that a function is even or odd, we have to use the algebraic tests instead. We have to use those as a way to start, and just the graphs are going to be more informal in this case. So here is the algebraic, these are the algebraic tests for even and odd. I would recommend that you write that down somewhere. We're going to take whatever function it is, and we're going to plug in for either of these two tests. We're just going to plug in a negative x and see what comes out. Now, if it's even, what will come out once everything's simplified is just the original function itself. That's what this statement means. If it's odd and we plug in a negative, what's going to come out is the exact opposite of the original function. So I want to give you a couple of quick examples for that, and we'll start with this one here. Now, I'm not going to tell you if it's even or odd. If you wanted to, you could graph this on your calculator and just get a look at it first. But I want to do this using the algebraic test. So here's my first step. No matter what, no matter if I think it's even or odd, I'm going to plug in negative x to this function, which means that I plug in negative x up here, and I also plug it into any other x's that I see in this problem. So there will be some problems, if they're polynomials in particular, where you have to plug it in several times. Once I do that, I want to simplify this expression. So I simplify it, and on the top is just, we can take away those parentheses, it's just negative x. On the bottom, we've got 1 plus, well, negative x squared. When you square a negative, if the negative is inside the parentheses, then it just turns into a positive. So it's just 1 plus x squared. And so now I've got this, this expression. Now the thing about this expression, since the top is just one term, I can take that negative and really just move it out into the front. I can place that negative on any piece that I want to here. So as I finish this one up, I'm just going to put parentheses around that so that we can see a little bit more clearly what we're dealing with. So now that I have this, this is what comes out the other end, and so we got to look up here at our test and decide, all right, which one is this? Now the original function was x over 1 plus x squared. Well, the bottom here is that exact thing except negative, so this is exactly opposite of what the original was. So what that does is it verifies that this one is in fact odd. So the test here shows odd. All right, well now you're probably wondering, what does an even one look like? So I'm going to give you a quick example of what an even one, how that would come up. And so an even one could be, we'll call it the function g of x equals x squared. So I'm going to start this out in the same way as the first one. I'm going to plug in a negative x for wherever I have an x in this problem, and so negative x squared. And kind of like the last one, do a negative x squared, that turns it into a positive x squared, and you'll notice that the original is x squared, the new one is x squared, and that means that this one is even. So the algebraic test is really the way that you prove to me that something is even or odd, but the graphs are a really great way for you to just get an idea before you start doing the algebraic test, and that can be helpful as you're trying to show those things even or odd.